Right, now let's move on to adding and subtracting fractions. So coming back to our example of cakes, okay, let's say that this time we've got 2 cakes, okay, and we've got, in the first cake, we're cutting it in half, okay, and in the second cake, we are cutting it into 3 parts, and we're taking one of those pieces, okay, and now what we're going to do is we're going to add those 2 bits of cake together, right? Now, since these 2 pieces are of different size, it's not obvious exactly how much we're going to get as a result, right? I mean, we can see from the picture roughly how much cake we're going to get, right? But to be precise, it's a little bit hard because these pieces are of a different size, okay? Now, what if we slice the cake a little bit differently? Okay, so in this case, we're slicing it into 6 parts, okay? And the half is equivalent to 3 of the 6 pieces, and the third is equivalent to 2 of the 6 pieces. Now, it becomes much easier to add these 2 together because we're adding pieces that are the same size, and adding 3 and 2 together makes 5. Okay, so that is why when we're adding fractions, we need to turn them into what's called a common denominator. Okay, and in this case, the common denominator is 6, right? So let's go back to that example and see a little bit in more detail how we do that. From a mathematical point of view, we're adding a half and a third. We want first a common denominator of 6, so we want both of these fractions to be written with a 6 at the bottom. Okay, how do we do that? Well, first of all, we're going to transform the first fraction. Okay, we want it to be 6 at the bottom rather than 2, so we multiply the bottom part by 3. Okay, because 2 times 3 is going to be equal to 6. However, if we just do that, we're going to change the value of the fraction, right? So to not change it, we need to also multiply the top by 3, okay? And in this case, 1 times 3 is equal to 3. So we end up with 3 over 6, okay? Which is the same as what we saw in the animation earlier, if you remember. Now, the second fraction was 1/3. And in this case, we also want the same denominator of 6 to be at the bottom. Right? So to go from 3 to 6, we multiply by 2. And again, we don't want to change the value of the fraction, so we also multiply the top by 2. Okay? And so 1 times 2 equals 2, and 3 times 2 equals 6, so we end up with 2 over 6. And notice that 2 over 2 and 3 over 3 are both equivalent to 1. Right? So both of these fractions, we're multiplying them by 1, so we're not changing the value, we're just changing the form. And now that they're both over 6, we can add them together easily. Okay, so there are always many different common denominators that we can use. Right? In this case, we're using 6, but we could have used, for example, 12. Or we could have used 24, we could have used 48, we could have used a number of different denominators. Now, there are methods for working out what is the smallest common denominator. Okay, we'll come to that a bit later. But for now, the simplest thing to do is just to multiply the 2 together. Okay? Right, let's see another example. So let's see this one here, where we're subtracting. But it's going to be a very similar principle where we need to look for a common denominator. And in this case, so we could multiply 4 and 6 together to get 24. But you may have noticed that here we can actually use a smaller one, which is 12. Okay? Now, first thing we want to do is we want to transform the first fraction into something over 12. So we multiply top and bottom by 3. To get 9 over 12. And then for the second one, we need to multiply top and bottom by 2 to get 2 over 12. And now we can subtract the 2 one from the other. So we keep the same denominator as is, and we do 9 minus 2 in the numerator to get 7 over 12. One last example. As you can see from this one, well, sometimes in the GMAT, you don't have all the numbers in the fractions that you're adding or subtracting. And in this case, we've got A and B, and we don't know what they are, so they're unknowns. But we can still add them. How do we do that? Well, we don't know what values they are, but we know that when we multiply the two denominators together, that is going to be a common denominator, and that will work. So in the same idea here, we're going to multiply top and bottom by b over b, which is b over b is 1, right? So it's not changing the value, but it's changing the format, and we will get something over ab as a denominator. We can do the same thing for the second fraction. So in this case, we start with b and we want ab as a common denominator. So we multiply by a, top and bottom, and we get 3a over ab. Now, we both have the same denominator ab, so we can add the numerators to get 2b plus 3a over ab. So pretty much the same thing as if we had numbers. It's just that some of the numbers are hidden behind these letters. We still have to look for a common denominator, and the simplest way to do that is just to multiply the two denominators together.